Question 10, the graph models the time t in minutes required for a sample of the radioactive isotope francium-223 to decay to a proportion p of its original mass. Approximately how long will it take a 100-gram sample of francium-223 to decay to 20 grams? Let's get this straight right off the bat. Francium-223, let's just get rid of the 223. That's just the name of the isotope. Let's just call it francium. Second thing, and this is really what trips most people up. We have two variables. We can see here time, t in minutes, and p proportion, the proportion of this substance that's decaying. Time is almost always on the x-axis, except it's not here. You can see it's on the vertical y-axis. So time is our y-axis, and then our x-axis is represented by the proportion that is decayed of this substance. So where we're starting this graph, normally we start on the left side and move right. Here we're starting on the right side. Because if you think about this point here, this represents 1, we have 100% of this substance to begin with. And then it's in line with 0 on the time axis because time hasn't started yet. So this problem we're moving from right to left. So the question, let's get to it. Approximately how long will it take a 100-gram sample? So that means we're starting here with 100 grams. And we're decaying to 20 grams. So we've gone from 100 to 20. You can do that math in your head. But we've decayed by 80. And 80 over 100, we've decayed by 80%, or by 0.80. So we've gone from 1 unit, and we've subtracted 0.8. We've decayed by a rate of 0.8, and we end up at 0.2. That's how much the substance we have left. You may not have had to do all that math. You may have just thought, hey, we've gone from 100 grams to 20 grams. We've reduced by more than half. So I know I'm way down here on the left-hand side of the graph. So then finally they want to know, okay, how much time did it take to get to this decay rate, to get to 20 grams of this substance? Well, we just look here on the curve. Curve at 0.2 corresponds at this point. We look to the left to figure out how much time that is. 50 seems to make the most sense. 30 makes no sense. That would be underneath 40. 20 makes no sense. 70, it'd be between 50 and 70, but that clearly looks like 50 because they're counting by 20s. So I know right in between that 60s, yeah, so 50 makes sense. 50 is the answer.